warm good evening to all the students, parents, alumni, and all my colleagues. Myself, Professor Pottiga Vinayak, working as an assistant professor in the Department of Computer Science and Engineering, Nbnscoe Solapur. So I take this opportunity to welcome you all in this 1 week webinar series organized by Department of Computer Science and Engineering, Nbnscoe Solapur. And this is day 5, and today we have with us our alumni, Mr. Chaitanya Pathak. I welcome you, Chaitanya.
Hello, sir. Thank you.
Yes, welcome. Now I'll request. So before this, I'll welcome our honorable HOD, Professor Amol Pathak sir. Along with we have Sanjay Bavre sir, Mahindargi sir.
Nbnscoe Engineering College for giving me this wonderful opportunity. I would also like to thank our principal, Dr. Navle sir, and HOD of CSE department, Pathak sir, and also the coordinator of this event, Vinayak Pottigar sir. And also I want to give special thanks to Joshi ma'am for putting up my name here for this wonderful opportunity. And good evening all. We'll start the session. I am starting my presentation. Okay. Okay, I hope you are able to see my screen. Okay. Currently, we are going to discuss about two topics. Basically, introduction to telecom billing, and second topic is what we call it as Kubernetes. Okay. So now, what telecom billing is. So if we think about the logos, we are able to see in my screen, that is Airtel, Idea, and Vodafone and Reliance Communication. What these companies are doing. So these companies are providing the telecom services. Okay. So what telecom services include? Okay. We can consider it as a voice call, right? Data services, SMS, MMS. So MMS is nothing but the multimedia message. Though we are not using that kind of service nowadays, but it was there previous of the WhatsApp. Okay, the WhatsApp is a new app we are using day to day. So these MMS are not coming. Okay, so these are the basically popular services provided by these telecom industries, right? So if we are thinking about these telecom industries and services provided by them, we will think about how it will impact in my day-to-day life, right? So okay, we'll consider a scenario. Okay, I need to buy a new SIM card and I need to go to the Airtel customer for that, right? So if I am buying a new SIM card, I need to go to the Airtel customer. I will buy a SIM card. Okay, what they will do, they will give me a SIM card and they will register me as their subscriber. Okay, which means that they are going to provide me the services, and that services I am going to use, and I am a subscriber. They will be the service providers, right? So we have not only these services. If we go on to the large scale, okay, so we have more services as well there, like satellite communications and radar communications, right? So we will think a scenario, right? What mediation do, as we discussed earlier, the network will collect all the details of the call you have made, all the data you have used, and they store it as a CDR, which is nothing but the call detail records. Okay, and that call detail records will be sent to the billing system. Okay, so now they will send that data in their format. Okay, but billing system need to manipulate that data, need to normalize that data, we can say need to purify that data in the fashion the billing system wants. Okay, so now if a network is sending 10 records to me, that is a 10 call made within a day or within a 2 day. So I need to check, I as a billing system need to check, okay, this is a call made from which region to which region it is made. It is comes in the inter roaming section or outer roaming section. If it is comes outer roaming section, I need to apply some different rules. I need to put some additional charges to that, right? So in that way, this works. So mediation system, what is does is it will take the raw data from the network, what we call it as is a CDR, that is a call detail record. Okay, it will take that raw data, refine that data, and it will go give it to the billing system. Okay, so now second module comes as a rating. So rating, what will do? Rating will identify the regions. Okay, from A party we have called to the B party. For this much duration we have called. Okay, suppose we are considering 1 minute 1 rupees. Okay, so if that call is exceeding by 1 minute, okay, then we need to charge for second minute also. So rating, what will do? They will create charges to the customer, and it will charge for 2 minutes here. If your seconds are more than 1 minute, that is a 60 plus seconds, they will charge for whole 2 minutes. So in that fashion, the rating will work. So rating will basically do the creation of charges to the customer messages. So whatever it may be, the GPRS data, whatever the SMS you are sending, or whatever the voice calls you are doing, on the basis of that, it will provide, it will generate the charges to the customer. Okay, now the thing comes is a third module comes is a billing module. Okay, what do you think billing will do? Okay, billing will do, if I have a telephone. Okay, now we will just go back to some previous scenarios. Okay, if I have a telephone, then the telephone, which company, suppose BSNL is providing me that gadget, and they are they are expecting some charges from me, right? They will not just provide me the gadgets, and they will not just charge me the usages I made for that current month. Charge me the installation charges, right? So if you are taking any new connection, there will be some installation charges. That are the one time charges. In future, we are not going to pay that charges again, right? So first charges comes is the installation charges, that is the OC charges. That is, sorry, one time charges. Okay, so the second thing is recurring charges. Okay, if I have a device and I am going to use it for years and years, okay, for per month they will charge me suppose 199 rupees. Okay, this we call it as a recurring charges. Okay, so every month, as I am I am currently taking their device for use, so they will charge 199 rupees. Okay, so that will call as a we call it as a recurring charges. So billing, what will do? The rating is done the charging of usage events, right? Whatever the call, data, and SMS I have used, the rating has done that charging. Okay, billing, what will do? Billing will consider that rating charges as well as the charges which are recurring charges, which are installation charges, and finally it will club all the charges for that particular customer. Okay, so billing will do the aggregation of all the charges, and it will give to the invoicing section. So the output of billing will be the XML file, and XML file will be sent to the invoicing section. So invoicing section, what it will do? It will just print that XML into the PDF format. Okay, so that is the task of invoicing. So finally, after invoicing is done, means the fourth module has produced their output, then finally we will directly get the invoice in the output. That is, we will get the invoice in our mobile. Okay, in this way, this all four modules work in the telecom billing industry. Okay, so we are having two topics to consider in today's session, right? First one is a telecom billing industry, introduction to that. So I hope this is clear now about the telecom billing industry introduction. Okay, so now second part is Kubernetes. Kubernetes is nothing but the container orchestration engine. Okay, so I will try to connect these two topics, that is how we work, right? So if I am deploying any app to the new system, I need to have my all the code there. So what, and all the required things like my SQL database, my Oracle whatever is required, my Oracle database, my SQL database, my messaging server, my cache layer, my all these things are clubbed, and whatever the jars and libraries are required, that I will club, and I will do UT on my UT environment, that is unit testing, and I will build the package of that my application, okay, which contains all the dependency that application requires. Okay, and finally I will deploy that, I will make the Docker image of that. Okay, so what Docker image will do, Docker image will contain all the things which are required to run that application, and that we will put into the build phase. Okay, so Docker architecture is containing of 3 phases. First one is a build phase, which will contain the Docker image. Okay, then now next thing is a ship. We need to ship this. Okay, so I have package of the application which contain all the dependencies. If I deploy this package directly on any of the operating system, it will directly work, it will not stuck with any issue. Okay, so this Docker image I need to put in the some repository. Okay, so that my colleagues, my teammates, or any of the person whom I want to share this application, that I can share, right? So I will put that Docker image into the Docker Hub. We call it as a ship phase. Okay, this ship phase will all time it will contain the data you are sending, right? So it will contain the package you are sending, and anyone, whoever is having access, they can download it and directly run that application. And here it comes the third phase called as a run. Okay, so I have this package contained in the ship phase, that is a Docker Hub repository. So I will take this package and I will directly run in my containerized environment. Okay, this run phase will, what will it contain? It will contain a running copy of the application with having all the dependency included into the Docker image file. So we will not face any such issues that, okay, we have an application and this dependency is failing to install the application, running the application, right? This thing will not come into picture. So this helps us to maintain the particular containerized environment, which will have all the related stuff of that application without any failure. We can run it everywhere we want to run, right? So next come is the Docker engine. So as we discussed in the previous slide as well, so Docker container, we can have the multiple containers in the Docker engine. Docker engine, what it will do, it will contain multiple multiple containers, and it will contain the multiple apps on it. So it will virtualize at the operating system level. So what we are decreasing here, the cost of operating system we are decreasing, the cost of many virtual machines we are decreasing, and third is a big advantage is, if we want to scale up the application. For example, I have one example here. Okay, so in the next slide we have example. Okay, so if I suppose we'll go to the, if you are aware of the example called as Pokemon Go game, right? Back in 2014, 15, 16, we were having this game. It was very popular game, right? So this game was expected the traffic of 1x at the start, but it goes very popular, it goes very viral, we can say, in our world nowadays, and it got the traffic of 50x directly. What they were supposing x traffic, and they got 50x. So obviously their infrastructure was not there to handle 50x traffic, right? And all the game collapse, all the games goes down. It run the game on any of the mobile, any of the system, right? What they need to do for that, they need to increase their physical servers, they need to increase their RAM, they need to increase their CPU power. Okay, so for that, what they need to do, they need to bring down the system, right? So this is the problem here. If we are bringing down the system which is already live on the production environment, that will cost us very much loss, you can say. So I can like feel that loss, right? If you the environment for particular time of the downtime, you need to bring back that app, and you will not provide any services to your users. So that is very hectic scenario, and that any application should not face that scenario. So in that fashion, they face the thing that they need to bring down their application for certain amount. They increase
Chaitanya,
their
your voice
CPUs
is
and
not audible. Hello?
okay. Am I audible now?
Hello? Can you hear me, Chaitanya?
Yes, yes, I can hear you.
Hello?
You're audible? Okay. 1 second.
Hello, Chaitanya. We'll try to reconnect Chaitanya as soon as possible. Stay here.
You able to hear me now, sir? Am I audible?
Yes.
Chaitanya?
Yes, okay. Yes, am I audible now?
Yes, yes.
Yes.
You're audible.
Okay.
Now you share your
Yeah,
screen.
I'll share. Yes, yes. Now I will share my screen once again.
Yeah, it's
So,
visible.
you can to see now.
Yes, clear.
Okay. So we were talking about this Pokemon Go, right? So at that particular time, they need to bring down the application, which is nothing but the very much loss to the company. Okay. So now what they were trying to do is they need to increase their physical servers, right? So okay. So here it comes the Kubernetes. Go to this previous slide. Okay. So now I have many Dockers, like I have many containers and I have multiple apps with me. And I have multiple VMwares as well. Okay, consider this scenario. Okay, I have multiple apps that are containing multiple servers that are containing multiple containers. Okay, for example, suppose this one section is containing multiple apps and that is nothing but the container. Okay, we have multiple apps, we have multiple servers as well, physical machines as well, VMware, cloud service, all these things we have, but we need to manage all these things. Okay, there the concept comes as container orchestration engine. So Kubernetes is nothing but the application developed by 14, but it has become popular back in 2018. But nowadays it is very boom in market. So you can use the Kubernetes for large application, large organization to manage their application in very good scale. Okay, so here two things are coming: the clustering and scheduling. As the Pokemon Go has faced the problem in their increasing their infrastructure. They need to bring back have done at that time. They would the largest application running on Kubernetes is the title of this slide suggests me that only, right? But they opted for this. Afterwards, they have faced this issue. Application first only because in this we have few advantages in the Kubernetes. First one is a clustering and scheduling. Okay, suppose we'll go to the clustering. What clustering does? Clustering two nodes, that is a master node, go into deep live stream that application or stream that particular video without any faults. Okay. So in that way, this API server reads that data and it will check for the worker node which is having that capability. Not all the containers will have same physical servers or same physical capacities, right? So maybe Gmail will require some less physical capacity because it is having only mails. It is not needed to stream the live data or stream the video live, right? So it will have some less resources, we can say, right? So in this fashion, so Google will do setup of their Kubernetes object, right? So this is all about we can how we can install any application. I have told you by one example. Some commands. So if you are thinking, okay, this PPT is good, all the things are good, so how we are going to manipulate all these things, or how we can see the actual picture? Okay, this is my pod, this is my service, this is running, this is down. How we can see that will I show in the one application. Before that, we will see some commands. Okay, so I want this is this previous thing, right? You have seen this kubectl. What this kubectl will do is kubectl will allow me some commands. Kubectl is nothing but the actual running engine. Thanks to the Kubernetes architecture we have, Kubernetes cluster we have. So in that we can create, we can delete, we can describe the pods, we can delete the, we can get the details of that pod. Okay, so here see, kubectl is a command by which we can create the pods in this. Kubectl create -f and example.yaml. So example.yaml, what it will contain? It will contain all the configuration things. So it will this application needs the DVD drive. So this application needs to be installed on the physical server, which have capability to maintain the physical drive. So these all things will contain in this example.yaml file, right? So in this way we are going to create the pods. So as we seen in the these circles, right? These circles will contain actual containers. So now as we are thinking about this container, that containers needs to access of some physical servers. So in this way, this example.yaml file will tell me that okay, this pod need to be created on the worker node, which is having the physical server, which is having the capability to access the DVD drive or to maintain the DVD drive. Okay, so yeah, in that fashion we can create the multiple pods. Okay, so now get is the command. We have created some pods. So get is the command which will give me the detail about the pod. Okay, this pod is containing this application, this many servers are attached to it, this many the physical server of this memory.
Your sign-in was successfully verified.
That will happen in future now. So we'll be able to see the differences and all.